wanted to go over best fit lines and finding slope again. Just like we did in class, this will be a very similar example. Let's take a look at this graph first. I've got my labels, I've got my units, I've got my plotted data. I just don't have a title. So let's go ahead and put a title in here. The title of this would be the label on the y-axis. That would be mass versus the label on the x-axis, which is volume. So in general, my title is going to be the y-axis label versus the x-axis label. All right, so we've got that set. Now what I want to do is I want to put a best fit line here. We can see this is linear, but it's kind of all over a little bit. It's a little choppy. I wouldn't just connect the dots. What I want to do is get a best fit line here. I want to try to get this through the middle of the data, essentially. So I'm going to draw a straight line through the middle of the data. And my goal is to get as many points above the line as below the line. So I got 1, 2, 3 above. I've got 1, 2, 3, 4, 5, 6 below. And I might try to shift that down just a little bit. In fact, let me do that. I want to shift this down just a little bit. That might be just a little better. Let's see. I've got 2 points that hit, almost 3, and I've got 1, 2, 3 above. They're kind of far above. You know what? I probably need to shift that up just a bit more. And go take one more shot at this. So I got 1, 2, 3 above. Just barely nicking that. I got 4 below. And it's probably about as good as I'm going to get by hand. Obviously, there are calculators and computer programs that do a best fit for you. But for the moment, we're going to do this by hand. So I've got my best fit line. What I want to do next is calculate the slope. Just like we said in class, slope is rise over run, or change in position, or excuse me, change in y over change in x, which is where that y2 minus y1 over x2 minus x1 comes from. What we want to do is we want to choose 2 points on our line. I prefer not to choose data points because sometimes you just grab 2 random data points like this one and this one, and if you figure out the slope of that, that's essentially drawing a line through those 2 random data points, and you can see that line does not even come close to representing the rest of our data. It's a far different slope than the slope of this gray line that we are going to use as our best fit. So I'm going to get rid of that. It's not the way I'm going to do this. What I'm going to do is I'm going to choose 2 points, stuff that's easy to read. This one crosses a nice intersection here, so I'm going to use that point there. And let me find another one that kind of crosses nicely somewhere. Not seeing much. This is not good. Oh, it's kind of close, but I guess I'll use that one. I'd rather use something further apart, but those are the 2 easiest ones to read. So I'm going to go ahead and I'm going to just essentially read across there. And read across here. So that'll give me my change in y. If I read down here, this will give me my change in x. So let's go ahead and take a look at the change in y first. Change in y is going to be y2, which is 1.4, minus y1, which is 1.2, which is going to be equal to 0.2 grams. And then my change in x is going to be, is that 3.25? right? 0.25, 0.5, 0.75, 1.0, 1.25. Yeah, that's right. Minus, is it 2.75? Which is going to be equal to 1.50. I'm going to watch my sig figs here. This guy only had one decimal place, so my answer goes to one decimal place. That's fine because I'm subtracting. Rule is that you count decimal places, least limits. What I've got with the change in position, I've got, excuse me, the change in x, I've got two decimal places, so my answer should go to two decimal places, so I put that 0 in there. I'm now ready to calculate my slope. Again, slope, which for this particular graph is also going to be my density, is going to be equal to, I should include units here, this is milliliters for my x-axis. It's going to be my change in y over change in x, which is, we calculated to be 0.2 grams divided by 1.50 milliliters. I'm going to go ahead and divide these. So 0.2 divided by 1.5 is 0.1333 repeating. So that's equal to 0.1333. Now, sig fig wise, I'm dividing at this point, so I'm going to count sig figs and then least limits. I've got one sig fig on top, three sig figs on the bottom. One is my least number of sig figs, so that means my sig fig answer would be 0.1 grams per milliliter.